Okay, for the next few problems, I'm going to help you set up the dimensional analysis and get the problem started. And then I'm going to give you a few hints of how to find the numbers to complete it and come up with your final answer. Okay, always remember, start with a balanced equation. So on this first reaction, we have potassium chlorate that's decomposing, breaking down into potassium chloride and oxygen. To balance the equation, let's look at your reactants. I see I have 3 oxygen when I only have 2 on the other side. In order to make this an even number, I'm going to change this coefficient to a 2. I now have 6 oxygens on the reactant side. I need 6 oxygens on the product side, so I'm going to change that coefficient to a 3. I have 2 potassiums and 2 chlorines on the reactant side. I have potassium chloride together on the product side. If I change that coefficient to a 2, my equation is now balanced. Now the question that's actually on the front side of this page, it says that if you start off with 25 grams of potassium chlorate, always write what you're starting off with off to the side. It's asking you if that many grams of potassium chlorate breaks down, how many grams of potassium chloride can be produced. That's my question. That's what I'm going to be searching for. Now, once again, it may seem as if you can go directly from grams of one substance to grams of another, but you cannot. In order to get from grams of one substance to grams of another substance, you need to first go through moles. So I'm going to set up it to where I go from grams of potassium chlorate to moles of potassium chlorate, then moles of one substance to moles of another, and then I'm going to go back to grams. It sounds complicated, but let's see how we set it up. Okay? I think you'll find that it's quite easy once you get practice with these problems. Always start with what you are given, which in this case is 25 grams of potassium chlorate. Draw your horizontal line, then your vertical line. Remember that you're going to want units to cancel, so what's at the top is going to end up at the bottom on the next conversion factor. Now I want to go from grams of potassium chlorate to moles of potassium chloride. That's going to be my new unit on the top. Okay, without putting in numbers right now, I'll give you hints on those later. Let's keep setting this problem up. Now that I'm at moles of potassium chloride, that's going to be my next unit on the bottom. I can now go to moles of my other substance, which in this case is moles of potassium chloride. Okay, so these units are going to cancel. These units are going to cancel. I'm at moles of potassium chloride, but that is not what I'm looking for. So on this problem, I need to extend it just one more step to go from moles of potassium chloride to grams of potassium chloride. So once again, put moles of potassium chloride on the bottom, because that will eventually cancel. And then I can finally go to grams of potassium chloride at the top. These units are going to cancel. These units are going to cancel. These units are going to cancel. And I eventually get to the units that I'm actually looking for. Okay, now I have a bunch of blanks in here because now your job is going to go back and figure out what numbers actually go into this setup. Remember that to go from grams to moles, or to go from grams to moles over here, you need formula weight. You need to figure out what is the mass of 1 mole of potassium chlorate. So go and calculate the formula weight or the molecular weight of potassium chlorate. Remember to do that, use the periodic table, figure out the mass of each element, multiply it if there's multiple atoms of that element in the compound, figure out the formula weight of potassium chlorate and enter it here. Remember to go from moles of one substance to moles of the other. You're going to look at the ratio in the equation. So fill in what number goes with potassium chlorate and the number from the balanced equation that goes with potassium chloride. Finally, over here, you're going from moles to grams. So once again, for every 1 mole of potassium chloride, now find the formula weight of potassium chloride for this last conversion factor. So look on the periodic table, figure out the mass of potassium, the mass of chloride, That will be the formula weight of potassium chloride, which will be the mass of 1 mole of potassium chloride. Okay, so you need a number here, you need 2 numbers over here, and you need a number here before you can come to your final answer. Remember, eventually you'll multiply the tops together and then divide by the bottoms. Your units will be grams of potassium chloride. Okay, let's set up the next two. The next two use the same equation, so let's go ahead and balance it once. We'll use it for 2 different questions. It looks like I'm dealing with nitrogen, hydrogen, and ammonia. I see that I have 3 hydrogens over here. I need to make that an even number. I'm going to double the ammonias. I now have 6 hydrogens. Balance the equation here. And I need to go back and check my nitrogens. And I do in fact have 2 nitrogens here, 2 nitrogens on my product side. I'm done balancing the equation. I'm going to use the same reaction down here, so the same coefficients will work to balance my equation. Always start off with a balanced equation. Okay, number 6. I'm going to start off with 50 grams of nitrogen. So out to the side I remind myself, okay, I'm starting at grams of nitrogen. And I'm trying to calculate how many grams of hydrogen. So my question mark is grams of hydrogen. Okay, so I look at that and I say, okay, I need to go from grams of one substance to grams of another. I cannot go directly from 1 grams of one substance to grams of another. I'm going to have to work my way through moles like I did in the previous problem. So let's go ahead and get started with 50 grams of nitrogen. Horizontal line, vertical line. Put your units in the bottom that you want to cancel. Grams, there is a way to convert from grams to moles. In a minute, you're going to need to go back and find the formula weight of nitrogen and figure out the mass of 1 mole of nitrogen. Use formula weight or molecular weight. Next, conversion factor. Put the unit down at the bottom that you want to cancel. I'm trying to go from moles of nitrogen to moles of hydrogen. In a minute, when you go back and complete this problem, you're going to use the balanced equation to find your mole to mole ratio. Okay, I'm not quite at grams of hydrogen. I have one more step. Put the unit down at the bottom that you want to cancel. I can go from moles of one substance to grams of that substance. I'm going to do so by finding the formula weight. 1 mole of hydrogen is going to equal its formula weight. Okay, so before you do your calculation, you need to check that you've gotten the units correct. Those units cancel. These units cancel. These units cancel, so you'll be left with grams of hydrogen. So you're going to need to go back and figure out a formula weight here. Use the equation to get your mole to mole ratio here. Find a formula weight for hydrogen, and that will end up being your numbers you need to do your final calculation. Okay, I'll set up one more for you. It says how many grams of ammonia are produced in the above reaction. So if I still start off with the same amount of nitrogen, it's now asking me how many grams of ammonia I can produce. So I'm starting with the same information. Instead of calculating grams of hydrogen this time that are needed, I want to know grams of ammonia that are produced. Okay, this setup's going to be very, very similar here. You're going to start to see a pattern. 50 grams of nitrogen is what I'm starting off with. Horizontal line, vertical line. Whatever units I want to cancel, put those down below. I can go from grams of one substance to moles of that same substance. I need to do that by finding the formula weight. Put the mass, the formula weight of nitrogen down here. That will be the mass of 1 mole of nitrogen. Put whatever units I'm going to want to cancel down below. I can now go from moles of one substance to moles of my second substance, or in this case, from nitrogen to ammonia. I'm going to fill in the numbers here by using my mole to mole ratio for my balanced equation. And then my last conversion factor, I want moles of ammonia at the bottom because I'm eventually going to want that to cancel. My whole goal in this problem is to get to grams of ammonia. I'm trying to figure out how many grams of ammonia can be produced. Once again, to go from moles to grams, like we did over here, grams to moles, I need to use formula weight. So I need to use the periodic table. This time calculate the formula weight of ammonia. So fill in the number here for how many grams of ammonia is 1 mole of ammonia. So fill in a formula weight here. Okay. Once again, check your units. Those cancel. These cancel. Those cancel. I'm at the correct unit for what the question is asking me for. After you fill in the numbers for formula weight, mole to mole ratio, and the formula weight of the second substance, you'll be ready to calculate your final answer. Okay, so notice that in each of these problems, we went from grams of one substance to finally grams of a second substance, but the way to do that is to go from grams to moles, to moles to moles, and then from moles to grams. Okay, grams to grams, grams to moles, moles to moles, and then moles to grams.